Okay, so now we're going to turn our attention over to question 2. Factorize the following completely. We have 3x squared minus 6x. So let's dive right into it. 3x squared minus 6x. You guys will be either using a black or a blue pen. So let's get familiar with sort of like the paper that we're going to be writing on. Hence, I'm using this paper. So 3x squared minus 6x. Hopefully, this will make you reminisce and it will help you actually realize that you can do it. 3x squared minus 6x. So what we usually do is we look at the expression. This is an expression, guys. It's not an equation, an expression. We look and we ask ourselves, how many terms, okay, do we have in the expression? So there's 2 terms. Okay, that's the first question we need to ask. Question number 2, is there a highest common factor? So when you look at highest common factor, we look at the highest common factor sign, the highest common factor number, the highest common factor letter. What dictates the highest common factor sign is the term, the first term, right? If the first term is positive, we take out a positive. If the first term is negative, we take out a negative sign. Highest common factor number, we look at the coefficient 3 and 6, we take out the highest common factor number. And then lastly, the letter. What dictates the letter, the highest common factor letter, is the variable that has the lowest exponent. So let's look at that here. First term is positive, so our highest common factor sign is negative, is positive. Highest common factor number between 3 and 6, what's the highest common factor? So obviously it's 3. The number that goes into 3 and 6 is the highest number is 3. 3 goes into 3 how many times? Once. 3 goes into 6 how many times? Twice. Okay, that helps prepare us to know what's going to be left over inside the bracket. Then the highest common factor letter, we look at x squared and x. They are common, so therefore we take the variable that has the lowest exponent, and that is x. So our highest common factor is 3x. All right, and then number 3, what's left over inside the bracket? Since we have a highest common factor, we know there's going to be something that's left over inside. Now remember, when we take out a positive something, that means that the signs that are left over, remain same if we take out a positive highest common factor. But had we taken out a negative highest common factor, all the signs inside the bracket would have changed. Okay, so let's go. Highest common factor, we know it's 3x. We then open a bracket, what's left over? So 3 times what gives you 3? That's 1. X times what gives you x squared? That's x, because x times x gives you x squared. Then remember, we said the signs don't change. So 3 times what gives you 6, or 6 divided by 3 is what? It's 2. X was already taken out. Do we need to multiply another x to get x? Definitely not. So our final answer, guys, is 3x into x minus 2. Simple as that. That is factorized. That is really top-notch, straightforward. Let's go to number 2. We have x to the power 4 minus 16. Now, if we look at this expression, once again, we ask ourselves, how many terms in the expression? There are 2. Is there highest common factor? Definitely there is. Our highest common factor, guys, is actually 1. All right? The number 1, a positive 1, is our highest common factor. Definitely, definitely, definitely. So if you think about it, we can write then our expression x to the power 4 minus 16 inside the brackets, knowing that we've taken out a 1, which we don't write because we know that 1 is there. It's a positive 1. There's no variable, so we just write there's a 1 there unseen. So I'm just going to write that 1 so that we know that we've taken out a what? A highest common factor. Okay, and this is what's left over inside the bracket. Nothing has changed with the sign, but obviously 1 is an identity element. So 1 times x to the power 4 gives us that back. 1 times negative 16 gives us that back. Then we ask ourselves, inside the bracket, okay, so like I was saying, guys, this x to the power 4 minus 16, we can factorize further using what? Difference of 2 squares. Factorization. Remember, guys, that this is the difference. X to the power 4 is what we call a perfect square. Why? Because any variable that is raised to an even exponent is actually called a variable that is a perfect square. 16 is also a perfect square. Why? Because 16 is formed by multiplying a certain natural number by it itself. And what is that natural number? It is 4. So what we do is we open 2 brackets, guys. Okay, one will have a positive sign, the other one will have a negative sign, because our negative sign is, the constant is negative, so we know that there's different signs inside the bracket. Then what is the square root of x to the power 4? It's x squared. Okay, the square root of x to the power 4, guys, is equal to x to the power 4. Remember, when you remove the square root, we say x to the power 4 divided by 2. And then that 4 divided by 2 gives us x squared. That is the square root of x to the power 4. So we have x squared for the first term in each bracket. Then the next question is what? This is the square root of 16, that is 4. So then that gives us 4 and 4. Now if we look at each individual bracket, is there any further factorization that can be done? And guys, this is something we need to do in each and every step. We need to always ask, is there any factorization that can be done after having taken out the highest common factor? And we did find that there's difference of two squares. Now that we've performed difference of two squares, we look at each individual bracket and we ask, is there any further factorization that can be done? Now x squared plus 4, this is the sum of two perfect squares. We cannot factorize that. So that basically remains as x squared plus 4. But here, I'm sure you can see there's a difference of another perfect square and another perfect square. So what we do is we open a further two brackets so that we can factorize this last bracket, which has a difference of two squares. Okay, which is why I personally advise that when you do a difference of two squares factorization, make sure that the first bracket is positive and the last bracket is negative. Just in case that the last bracket is negative, we can factorize further by opening the last two brackets again. So here we can do that. So we're going to put a positive and a negative. Okay, then what is the square root of x squared? Because we can see a difference of two squares factorization with that second bracket. So what is the square root of x squared? We know that's x to the power 2 divided by 2 when we remove the square root. So that gives us 2 divided by 2 is actually equal to 1 is an exponent. So we have x. So that's x and x. Then what's the square root of 4? Well, the square root of 4 is 2. So that places 2 and 2 in the two brackets. Now the question is, can we factorize any further with these brackets? And the answer is absolutely not. So we end that question answering it right there. So guys, these questions, how many terms in the expression? 2. Is there highest common factor? Taking out the highest common factor, having left whatever is left over inside the bracket, then asking again, can we factorize further with what's inside the bracket? Yes, difference of two squares. We factorize difference of two squares. We square root the first term, we get x squared. We square root the last term, we get 4 and 4. We write two different signs, plus and minus. Then we check, can we factorize any further? Yes, we can there. So we open a further two brackets because it's the difference of two squares, and we can factorize a difference of two squares. We can't factorize a sum of two squares. So we open two brackets again, plus minus, square root of x squared is x, square root of 4 is 2, and then that basically brings our factorization to a beautiful end. Okay, so guys, those first two types of factorization, very important. I'll end this video here, and please tune in to my next video, part 3, so that you can witness further factorization. I believe actually next section, part 4.